Okay, so today we'll learn about the transportation problem. So before starting transportation problem, first we need to know what is transportation problem. Now see here, you have already learned about the linear programming problem, is it not? So in linear programming problem, what you have learned? Can you tell me, anyone? In linear programming problem, what we have learned? Linear programming problem.
To find
the
the values of variables that maximize or minimize the objective function.
In the last class also I have discussed about the linear programming problem. So in linear programming problem, the first part, there will be some objective function is there. Somewhat objective function is there, and then there should be some constants. There should be some constants, and then the third part is the non-negativity restrictions. Non-negative. So this is the three parts of a linear programming problem. These are the three parts that will be included in the linear programming problem. So first, objective function. So whenever you will formulate your linear programming problem, so obviously the problem is of either of maximization problem or it is of minimization problem. Is it not? It is of either maximization or minimization. Now, in the last class also I have discussed something about this. So maximization. Now see, for a very simple example I am telling you. If you are, you have suppose some company and you are manufacturing something. So you are, when you have established some factory, so what is your motive? In order to, your motive is to generate income from the what? Income from the company. That's your motive, is it not? Simple. So in order to generate the income from the company, that means you need to increase your profit. Now, how the profit will be increased? Profit, and so in order to increase the profit, now see, if you have a company of suppose you are manufacturing, suppose chair and table, plastic chair and table. So in order to manufacture that plastic chair and table, what you need to do? First, you need to procure the raw material from somewhere, and then after manufacturing, you need to transport the product at several places. Now, in order to do all this, your aim is to generate more profit, maximum profit from that. Now, in order to generate maximum profit from that, what you need to do? You need to minimize your transport means cost. Whatever with the cost is involved. If you minimize the cost, then your profit automatically it gets what? Maximized. Is it clear to all of you?
Yes, sir.
So whenever there is a problem of profit, then the objective function is what? It is of kind of what? Maximization problem. It is of kind of what? Maximization problem. Whenever there is what? Profit is included. In the problem, if profit is included. And when cost is included in the problem, when cost is included in the problem, then it is of kind of what? Sorry. It is of kind of what? Minimization. Whenever cost is included, then the linear programming problem is of what kind of? It is kind of minimization problem. That means if you are transporting your manufactured goods from one place to different places in order to sell that, so what? Transportation cost will require there. Now the question is what? So already you come to know that what is minimization problem and what is maximization. Whenever profit is included, the problem is of maximization, and whenever cost is included in the linear programming problem, then it is of minimization problem. That is very simple. Now in this unit, we will learn about the transportation problem. Now see, transportation means cost is involved. Is it not? Transportation means what? Cost is involved. That means in this unit, we learn about all the objective function is of what kind? It is of kind of minimization problem. All the problems are of kind of what? Minimization problem. Is that clear up to this? So in this transportation problem, our objective function is of what kind? It is of kind of what? Minimization problem, because it is of transportation problem, so cost is included here, so the problem is of what? Minimization problem. So our objective function is minimization. Now the problem is now here, how you'll minimize, how you will minimize the transportation cost. For an example, let us see. Okay, before that, let us see just one model I have prepared here, one table, and this is the, if you understand this table, so your transportation problem becomes very easy. Now see here, these are the sources. Now see here, if you see this S1, S2, S3, S4, these are sources. Sources means what? From where you can transport your manufactured goods. So these are S1, S2, S3, S4. S1, S2, S3, S4, these are your what? Your transportation, sources from where you can transport your manufactured items at different places. And this is the destiny, D1, D2, D3, D4. These are the destiny. Okay, these are the destiny where you need to supply the manufactured product. And these are a small a1, a small a2, a small a3, and a small a4. These are the supply. Okay, supply means what? It says that this A1, supply means A1. That means from the source S1, you can supply maximum of how many units? A1 units. It may be whatever it may be. So from source S1, the capacity of the source S1 is to supply how much quantity? A1 quantity. Similarly, from the source S2, the capacity of the source S2 is to supply how much quantity? A2 quantity. And similarly, from source S3, you can supply maximum of A3 quantity. And from source S4, you can supply maximum of how much quantity? A4 quantity. Is that clear? What are these? A1, A2, A3, and A4? These are the supplies from different sources. Unit of supply from what? Different sources. Now these are the destinations. Destiny you can say, or destination. That means these are the D1, D2, D3, D4. And these are the what? This is the demand. That means obviously from you need to what? You need to sell your product. So obviously you need to sell it to some destinations at the different places. So these are the these are the different destinations D1, D2, D3, and D4. And for each destinations, the requirement, or you can say demand, is given with below here. These are B1, B2, B3, B4. Let me. So these are the what? This is the your what? This is your demand at different places, different destiny. So at D1 places, the total demand is how much? It is of B1. At destiny D2, the total demand is what? B2. At destiny 3, the total demand is what? It is what? B3. And at destiny 4, D4, the total demand is how much? B4. Is that clear? This what is D1, D2, D3, D4, what is B1, B2, B3, B4. So this B1, B2, a small B1, B2, B3, B4 is nothing but the demands at different places. Now, the next part is your this what are these C1, 1, what is this C12, C13, C14. So these are nothing but Cij. I have written here. Cij is nothing but denotes the what? Transportation cost. That means what? From source S1 to source D to destiny D1. If you need to supply some quantity, try to understand. From source S1, if you are transporting your manufactured goods to the destiny D1, then the transportation cost per unit, is how much it is? C11. Similarly, from source S1, if you transport to destination D2, then the transportation cost for 1 unit of goods is how much? It is C12. Similarly, from source S1 to source to destiny D3, the transportation cost is how much it is? C13 for 1 unit. And similarly, from source S1 to destiny D4, the transportation cost for 1 unit is what? How much it is? C14. So these are nothing but the transportation cost per unit. Similarly, if you need to transport from source S2 to the destination D1, then the transportation cost is how much it is? C21 per unit. Similarly, from source S2 to destination what? D2, the transportation cost is how much it is? C22 per unit. And similarly, from source S2 to destiny D3, the transportation cost is how much it is? C23. And from source S2 to destination D4, the transportation cost is what? C24 per unit. Similarly, these are the transportation cost for what? For transporting your manufactured goods from source S3 to different destination D1, D2, D3, D4. Okay. Similarly, this is the transportation cost per unit for what? Transporting your manufactured goods from source S4 to different destination D1, D2, D3, and D4. So this is the nothing but the tabular form of your transportation problem. So if anyone have any doubts, so they can ask here. Okay, so here I have already mentioned here, the Cij, this means all Cij denotes the transportation cost let me write per unit, okay. And these AIs are the what? Are the supply quantity, and BIs are nothing but your demand quantity, and these DIs are nothing but destination, and these SI are nothing but your sources from where you can transport your manufactured goods at different places. Now, this is nothing but the general form, the general tabular form of a transportation problem. Now, let us give me one example about the transportation problem. Now, suppose you have one manufacturing company of, say, example of that chair and table, say a plastic chair and table. So obviously when you manufacture it, the product, what you need to do? Obviously you need to sell it. For selling, you need to transport at different places. But our motive is to what? To get maximum profit from that. Now, in order to get the maximum profit from that, what you need to do? If you see, there's some big company, what they are doing, they have at one place their manufacturing unit is here. Suppose the manufacturing unit is here. So all the products are manufacturing here. And then what they have done, in some big cities, they have their own warehouse. They have their what? Their own warehouse. What is warehouse? Obviously you know that. Where they store their what? Where they store their manufactured goods in order to supply with respect to what? To the demand. So you can so your manufacture plant is here, and what they have done, they have made different warehouses in different places. Then what they are doing, they store their what? Manufactured goods there, and whenever demand comes from there. So now see here the motive is to what? Minimize the transportation cost. So when some demand will come from some places, say from the destination D1, some demand is coming. How much demand has come? Suppose B1 unit of that product required at the destination D1. So the company will see what? How to fulfill the demand of destination D1 with the quantity. So first the company will see which warehouse is very near to destination what? D1. Try to understand. The company will see which warehouses are very close to the destination D1. And then what they will do, once they have located which warehouse is close to the destination D1, what they will do, they will supply their demand. They will supply the demand of the destination D1. Now here the question is what? Maybe the warehouse, maybe the demand is more than the capacity of the supply of the warehouse. That means suppose S1 is the warehouse which is very close to the destination D1, but every warehouse has their own capacity of what? Supplying quantity of manufactured goods. So suppose sometimes maybe the demand of destination D1 is more than the capacity of the what? Of the source S1. Then in that case what? Then in that case what they will do? Okay, the source S1 has the capacity of what? Supplying the quantity, how much it is? A1. So what they will do? They will supply A1 quantity to the destination D1. But the demand of the destination D1 is more. So obviously some quantity is left for the from the demand. So what they will do? Whatever be the quantity left in order to fulfill the whole demand of the destination D1, what they will do? They will search again out of all the warehouses or out of all the sources, which source or which warehouse is close to the destination D1. Say the source S3. Suppose, I'm not telling that. Suppose the source S3 is close to destination D1 other than S2 and S4. So then what will do? The source S3, from source S3, whatever with the left demand, they will fulfill from source S3 if it has the capacity to fulfill that demand. So they will do what? They will supply the rest quantity from source S3 if it has the capacity of supplying. If not, then again, whatever it has the capacity of source S3, it will supply that quantity, and then again we will search which warehouse has the is more closer to destination D1, and then from that warehouse will fulfill the demand of the destination D1. In that way. So in that process, what will happen? Your transportation cost will become what? Minimum. In that process, your transportation cost become minimum because the source S1 is very close to D1. Then S3 is again closer to D1 than S3 is also closer to D1, but S1 is more closer to D1 than S3. But this S2 and S4 are not more closer than what? S1 and S3. So if you supply from S2 and S4, so obviously your transportation cost becomes what? High. And so your profit becomes less. So that's why. In that way, the transportation problems are arranged in such a manner that your transportation cost become minimum. Is that clear, this table? Anyone have any doubt? Kiba doubt ase kunba karba? Okay, now see, the next part is the general form of a transportation problem. What is the general form? So it's very simple. So obviously already I told you that it is of kind of what? It is of kind of minimization problem. It is a kind of minimization problem. So now see, so obviously the objective function you need to what? Minimize. So that minimum z now is equal to what? Is equal to what? What I have written? If you see this table, so these are what? C11, C12, C13, C14. These are what? These are nothing but the transportation cost per unit. Okay, these are what? Transportation cost per unit from the source S1 to different destination D1, D2, D3 and D4. So what? So let us say here what I am saying. say X11. Now see if you get disconnected, so again join with the same link. If you get disconnected. Sorry. Like this. So suppose from source S1, try to understand. Suppose from source S1, how much quantity has been transported or supplied? Risiraj, don't write anything. Suppose from source S1 to destination D1, how much quantity has been supplied? X11 quantity. Now this C11 is the what? Is the transportation cost of what? Transportation cost of what? 1 unit. So total transportation cost from S1 to D1 is what? C11 into what? X11. Similarly, from source S1 to destination D2, from source S1 to destination D2, how much quantity has been supplied? X12 quantity has been supplied. And the transportation cost is how much? It is C12 per unit. So the total transportation cost from source S1 to destination D1 D2 is what? C12 into X12. Similarly, from source S1 to destination D3, the total quantity has been supplied is X13, and the transportation cost is how much? C13 per unit. So the total transportation cost is how much it is? C13 into X13. Similarly, for D4, it is C14 into X14. Similarly, you can write here also, it is say X21, then X22, then X23, then X24, then here how much it is? X31, X32, X33, X34, X41, X42, X43, X44. So similarly from source S2, similarly from what? Source S2 to different to what? Source S2 to what? Different destination D1, D2, D3, D4. That what you can find the transportation cost. Similarly, from source S3 to different destination, you can find out the total transportation cost. And then from source S4 to destination D4, so to different destination, you can find out the what? Total transportation cost. So in that case, the total your objective function will be of what? Is of this much. This will be now C11 into what? X11. If you understand that one, the transportation C11 into X1 plus C12 into X2, X12, C13 into X13, C14 into X14. Then from source S2 to different destination C21, X2, X21. If you get disconnected, please join again. C22, X22, C23, X23, C24, X24, C331, X31, like this. So total 16 term will come. So total, see. Okay, so Did you understand this part, the objective function part? How the objective function is formed from the table? So it will be same for each transportation problem. Like this, we need to write the objective function. Then, if you see the LPP model, LPP, then in LPP, first is objective function, then what? Some constant will come, no? So here, there are two types of constant will come here. In transportation problem, two types of constant will come. One is called supply constant, and other one is your, just a minute. Other one is your demand constant. There are two kinds of constants, supply constants and demand constants. Okay, now, now try to understand from the table. What is the first line I have written? Sorry. The first line I have written as x11 plus x12 plus x13 plus x14 must be is equal to how much it is? A1. I have written this. Now see here. Now see the table. If you see the table. This is the source S1, and from source S1 to different destinations, I have supplied some quantities. What are the quantities? To the destination D1, I have supplied how much quantity? X11 quantity. At destination D2, I have supplied X12 quantities. At destination D3, I have supplied X13 quantity, and at destination D4, I have supplied X14 quantity. Now, the total capacity of source S1 to supply how much quantity? A1 quantity. So that means the sum of these supplied quantities to different destination must be is equal to what? A1. So that's why X11 plus X12 plus X13 plus X14 must be is equal to what? A1. Similarly, the other your supply constants are what? From source S2 to different destination, how much quantity you have supplied? Just you add all this, that must be equal to what? A2. Okay, so X21, X22, X23 plus X24 is equal to what? A2. Similarly, from source S3 to different destination, how much quantity you have supplied? Just you add all this, and then that must be equal to what? A3. And similarly for S4, the total supplied quantity must be at different destination must be equal to what? A4. Buzi paisa? Buzi paisa na na?
Paisa, sir.
Okay. Next is only what? Demand constant. There was another demand constant. So now see, this is the, so here row represent the supply and column represent what? Demand. Okay, so this is the demand. This is the demand. The column represent demand, and the row represent what? Row represent supply. Row represent what? Supply. Row represent supply, and the column represent demand. So now see here. So at destination D1, from different sources, some some product has been delivered or supplied. So from source S1, how much it has been supplied? X11. From source S2, X21 quantity has been supplied. From source S3, X31 quantity has supplied. From S4, X41 quantity has supplied. And total demand is how much? B1. So that means x11 plus x21 plus x31 plus x41 must be is equal to what? Must be is equal to B1. Here D1, because the demand of D1, destination D1 is how much? It is B11. So from different sources, the product has been supplied to the destination D1 in order to fulfill their demand. So demand is how much? B1. And from different sources, some quantity of product has been delivered to destination D1. So total demand of that must be equal to what? In order to fulfill the demand of the destination D1. So what? Total product delivered to the destination D1 from different sources must be equal to what? Must be equal to what? B1. Similarly, from different sources, product has been delivered to the destination D2 and the demand of destination D2 is how much? B2. So the product has been delivered from different sources to the destination D2 in order to fulfill the demand of the destination D2. That means x12 plus x22 plus x32 plus x42 must be is equal to what? B2. Similarly, from different sources, product has been delivered to the destination D3 in order to fulfill the demand of the destination D3. So that means x13, x23 plus x23 plus x33 plus x43, that must be is equal to B3. Similarly, from different sources, product has been delivered to the destination D4 in order to fulfill the demand of the destination D4. And so x14 plus x24 plus x34 plus x44, that must be equal to what? B4. So total here we have 8 constant, 4 for supply constant and 4 for what? Demand constant. Is that clear how to write the constant, supply constant and demand constant? Please reply to the question. No? If you have doubts, so you can ask me. Is there any doubt regarding this, how to write the constants?
No, sir.
Okay. So these are the supply constant and these are the demand constants. This is the supply constant and this is the demand constant as I have written. Okay. Now, the transportation problem is of two kinds. Okay, the transportation problem is of how many types? It is of 2 types. One is called one is called your balanced transportation problem and another one is called unbalanced transportation problem. So when a transportation problem is called balanced transportation problem and when a transportation problem is called unbalanced transportation problem. So in the transportation table, you have already seen there are some sources and from sources supply how much from different sources, how much quantity each sources can supply, then the destination where some demands are there. So whenever the total supply is equal to total demand, whenever the total supply and the total demand match up, or if total supply and total demands are equal, then that transportation problem is termed as balanced transportation problem. Is that clear? When total supply is equal to what? Total demand. That means whatever the company is manufacturing, all the products are what? Get exhausted with the demand. That means the company is totally fulfilling the demand of the destinations. So when total supply is equal to total demand then in that case, the transportation problem is known as what? Your balanced transportation problem. And when the total supply is not equal to total demand, so here two cases may arise. Maybe sometimes supply is maximum than the demand. Supply is more, but demand is less. Or in other case, demand is more, supply is less. These are the two cases can happen. Then in that case, the transportation problem is termed as your what? Unbalanced transportation problem. When supply is not equal to demand, then that transportation problem is called what? Your unbalanced transportation problem. Now, whenever you have a balanced transportation problem, if you have a balanced transportation problem, so that become very easy. There are different methods. I'll give you the name of the methods. There are different methods. Using that methods, you can find out the solution for the transportation problem. But if you have unbalanced transportation problem, where the total supply is not equal to what? Where total supply is not equal to total demand, then in that case, first you need to do what? First you need to, in order to solve the unbalanced transportation problem, first we need to make it what? First you need to make it as balanced transportation problem. First you need to convert it to the balanced transportation problem. Is that clear? বুঝি পাইছেন না? If your transportation problem is unbalanced, so in order to solve that transportation problem, first you need to make it balanced, and then you can apply the method, the method which we'll discuss later on. Then you need to apply that method to get the feasible solution for that transportation problem. Now, so the two conditions arise here. What are the two conditions? Maybe supply is more, but demand is less. The other case would be what? Supply is what? More, demand. Supply is more, demand is less. Other maybe supply less, demand is what? More. These are the two cases. So in order to convert unbalanced transportation problem to the balanced transportation problem, we need to insert dummy row and dummy column. So what is this? I'll explain in the table. So what you need to, in order to convert unbalanced transportation problem to transportation problem, to the balanced transportation problem, we need to insert dummy row and dummy column. So let us see the first case where supply is greater than demand. Where what? Supply is greater than demand. So when supply is greater than demand, so what you need to insert? We need to insert what? Dummy column. Okay, let's see in the this one. So this is the supply. So what is the condition? Supply is what? Condition 2. Dummy column karne supply is greater than demand. So here, this supply is greater than demand. Just a minute. Okay, let's see. So the first condition is what we are discussing. When supply is greater than what? Demand. When supply is what? Greater than demand. So here supply is more, but demand is less. So what you do? You insert one column here. You insert one column. And make the cost of each column is 0. The cost of transportation, just to insert 0 here. Here 0, here 0. Now see, supply is more, but demand is less, no? Try to understand. Supply is more, demand is less. So what? In order to equate this supply and demand, what you need to do? We need to generate some demand, is it not? Here supply is more but demand is less. So in that case, we need to generate some demand so that the supply and demand becomes equal. So that's why we need to say it is D5. Say I'm saying it is D5, destination D5. Say it is D5. Now, so here I have given the transportation cost are 0. All the transportation costs are 0 here. Okay. So in order to match with the supply, the total demand, since here the condition is supply is greater than demand. So in order to match with the supply, we need to generate some demand. So say B5. So say this is the demand. So once you have inserted this dummy column with the demand B5, with the demand B5 at the destination D5, your supply and your demand, becomes what? Equal. And so now it becomes what? It becomes your balanced transportation problem. So try to understand, whenever supply is greater than demand, that means we need to create some demand so that the total supply becomes equal to the total demand. In that case, we need to generate some demand, and for generating demand, we need to insert one dummy column. This column is known as your what? Dummy column. This column is known as your what? Dummy column. This column is called what? Your dummy column. This column is known as dummy column. Now the other case is what? When supply is less than what? Demand. That means demand is more, but supply is less. Then in that case, what? In order to match up with the demand, we need to generate what? We need to generate supply so that you can match up with the demand. So in that case, you need to insert one row. Are you getting my point? We need to insert one row here. Say, we need to insert one row here. And just the transportation cost, make it 0. Just here all the terms are 0. Make it 0. And create one what? Create here source supply, say A5. Say A5. Are you getting my point? What I'm trying to explain you? Since the supply is less than demand, so how to how to fulfill the demand? If you generate more supply, then only you can fulfill the demand. So in that case, we have generated more supply by adding one row, that is say source S5. So just to make all this 0, and then so this is the A5. So this is the A5, more supply has been given from the source S5. So now the demand and the supply becomes what? Your equal. And so your transportation problem becomes what? Your unbalanced transportation problem now become its what? Balanced transportation.
Balanced.
So in that way, whenever you have unbalanced transportation problem, so then you have to first, in order to solve that unbalanced transportation problem, you need to convert it into balanced transportation problem. So whatever be the condition will be there. If it is supply is greater than demand, if supply is greater than the demand, then you have to add one dummy column. So then this is called your dummy row. This row is called what? Your dummy row. Dummy row. I'm writing with the mouse, that's why this is called your dummy row. And if the condition is what? Supply is less than demand, then you need to insert what? You need to create more supply. And in order to create more supply, we need to insert one dummy row. So this is the way how the unbalanced transportation problem are converted to what? Your balanced transportation problem. Is that clear till up till that?
Yes, sir.
Okay. Now come to the part of, so next part is your different methods. Different methods for finding the basic feasible solution of the transportation problem. Now, different methods for finding the basic feasible solution of the transportation problem. Now, so let me write first number one. Number one is your north-west corner method. Okay. Number two is your least cost method. And number three is your Vogel's approximation method. Okay, these are the three rules, three methods. First one is your northwest corner method. Second one is your least cost method, and the third one is your Vogel's approximation method. Now, if I'll say, so these all three methods you need to learn here. So out of all these three methods, what I have written, different methods for finding the basic feasible solution. Now see here, all three methods, no doubt it will give the solution, but the problem is of what? The problem is of transportation problem. So Our aim is what? Our aim is to minimize the transportation cost. So from all these methods, you will get the solution of the transportation problem. But all this method will not give you the lowest transportation problem, lowest transportation cost. Or same problem can be solved. Same problem can be solved from these three methods, but the your answer will differ. Answer will differ from each method, in each method. So you are getting the, no doubt, the feasible solution. You are getting the, not getting the exact solution, but that feasible solution you are getting. But you need to test it, whether that solution you have got, whether that solution is the minimum one or not. Because as already I told you, same problem, if you solve from these three methods, answer will differ. That means what? That means obviously, no doubt you are getting the solution, but that solution is not the minimum one. So in order to test whether that solution is your minimum one or not, because our aim is to find the what? Our aim is to minimize the transportation cost as much as possible. So what we'll do, we will test the solution, what we have got from this all methods. So that test has been done with, that is called Modi method. That method is known as what? Your Modi method. Using Modi method, you can test whether the solution you have got from all these three methods, which solution will be the best suited solution for the transportation problem. Is that clear? So again, from these three methods, if same problem you will solve, I will take one example and I will solve by all these three methods. One example I will take and I will solve same problem with these three methods in next class. Then you will be able to find out what are the differences you are getting. So just for your understanding, just what I am telling, out of these three methods, Vogel's approximation method gives the better result in comparison to your northwest corner method and least cost method. Out of these three, Vogel's approximation method give us the more accurate, means give the best result in comparison to the other two methods. But that solution also we need to test by Modi method. But that solution also we need to test whether that solution is the minimum one or not. Is that clear? So these three methods we'll learn, and then we'll test with the Modi method whether these all solutions are minimum or not. Okay, so if anyone have any doubts, they can ask. I have finished here the first part. The second part we'll discuss about the different methods. If anyone have any doubts, so they can ask me. Huh? Karwaki Bata, anyone have any doubt? No one is replying. Huh? I think no one has any doubt. I think so, because I have taken around more than 1 hour to discuss that one, because but this is the hardly 30-minute class, but I have taken more than 1 hour to explain. So obviously, I don't think you should have any doubt. But even if you have any doubt, you can ask me, or I will share the recording of this class. I have recorded the class. I will share with all of you. And my request to all of you, for encouragement, just you subscribe the channel which I will give you. Please subscribe the channel, and you'll get all your class videos there also whenever I'll upload, and more videos you can get. Just you go through that. The whole LPP videos you will get there. Just now, for the time being, I have uploaded the basic LPP, the basic of LPP. One class video I have uploaded there. You can watch that one. I think your first unit video that I have uploaded in that channel. So you can go, you can watch that one. Obviously, you will get benefited from that. So I will share with all of you. Just you please subscribe the channel, and so and if you find any difficulty, just you watch the video, you'll get understanding. But even though after watching the video, even though if you have any doubt, you can ask me at any time. I will reply whenever I'm free. Okay. So should I stop here?
Okay, sir.